Hey everybody, Mr. Bowman here. Today's learning objective is in yellow and we are learning to identify irrational numbers, and then following that we're going to do a little bit of work on how to simplify these irrational numbers. So before we get to irrational numbers, we're going to start by discussing another phrase which isn't in our learning objective, but it's called rational numbers. And these are the types of numbers that we all kind of think about already. And we've got a whole bunch of examples of irrational numbers. So the most common one that you're thinking about are your whole numbers. So they're the most obvious rational numbers. The second one, fractions are really common. So let's maybe go 4/7. So your fractions, these are all rational numbers. And these here combined, they actually make up the definition of a rational number. It's a number that can be expressed as a whole number or as a fraction. Going beyond that, another example is, a decimal. This one here is called a terminating decimal because the decimals stop. So any decimal that stops is going to be rational. And the reason being, you can actually convert that into a fraction, right? And then the same thing with the last type of decimal that we need to know about. So 0.3 is a really good example. These are called recurring decimals or repeating decimals. So let's go with repeating. And the reason repeating decimals are rational numbers, the same thing there, any repeating number can be expressed as a fraction. So in addition to our typical definition of whole numbers and fractions, we can also link it into decimals because terminating and repeating decimals, all of those are going to be rational. I've added in that definition down the bottom there, and now this is going to segue us to this video's actual topic, irrational numbers. And I've got 3 examples of irrational numbers up here that I want to show you, and then I want to talk to you about how they differ from the definition that we've got there in red there. So the first example of irrational numbers, one you might be familiar with already, but that's an example of pi. And as you know, pi is a mishmash of decimals. It's 3.1415, and that number there goes on forever, doesn't it? So pi is one example of a rational number. The other one that comes up commonly less known is Euler's number, or we call it E, so you can put it in your calculator. And E is equal to 2.7182, again with a whole bunch of more decimals. Again, that one was Euler's number. And then finally, there's actually a whole bunch of other irrational numbers, and we call them generally surds. But for example, if we have the square root of 2, that there is 1.1442. Oh gosh, I've got that wrong actually. 1.4142. And again, that goes on forever. And then another example, root 3, and that's 1.7320, and that again carries on forever. One point of distinction here, so any surd, 2, 3, whatever, could be a irrational number, but be careful if you can actually do the square root. For example, if we carried on and did the square root of 4, that there is just 2. So that's actually a whole number. So square root of 4 would actually be an example of a rational number. But obviously, square root of 5, the next one, that would be an irrational number because we can't complete that particular maths. The interesting part about these numbers, they kind of differ from this one here. So these decimals here that I've circled, repeating numbers, recurring numbers, they go on forever and ever and ever. That's a feature of an irrational number. But what is different is these recurring, repeating numbers, there's a pattern to those decimals. So that 3 will go on forever, so you know what's happening here. Whereas these irrational numbers, pi, e, root 3, root 2, there's no repeating nature. There's no pattern within those decimals. So that's what makes it irrational. So let's start talking about that. So it's another way to do that is decimals without a repeating, or spelled repeating wrong there, without a repeating pattern. And that there's what we mean by an irrational number. So these numbers are special, and they're really messy to deal with because put them in your calculator, you get a heck load of kind of decimals spat out. but we can actually do a little bit of maths with them as well. So let's see this last bit in action. So this first question here, this here is adding two rational numbers together, adding two whole numbers. I won't bore you with that, but we know how to add whole numbers together. The next question is adding fractions together. Again, easy peasy, we know how to add fractions together. And the same with decimals. So that covered the irrational numbers. Those are the ones we know really well. But if we're adding all of these irrational numbers together, how exactly does that work? So the first thing to note is we could put 3 pi plus 2 pi in the calculator and it's going to get you a mishmash of decimals. But inevitably we'll have to round these decimals. So you're not going to get the exact answer or a perfect answer. You're going to have an estimate of the answer. So instead of rounding it and putting it in decimal form, what we can do is we can just group together the irrational numbers. So for example, this pi over here, that's actually just, well, 3 pi. So it's pi plus pi plus pi. This 2 pi over here is actually just pi plus pi. So we can see we've got the 3 pi and the 2 pi here. So combined, we've just got 5 pi. So this is a little bit like our simplifying or our grouping of algebraic expressions, but we can do it with our irrational numbers too. Same thing here is with e. So we've got 8e minus 5e. So 8 minus 5 is 3. But because we're dealing with the irrational number e, it's going to be 3e. Same with root 2. We've got root 2 plus root 2. So we're going to have 2 lots of root 2. And then finally down the bottom, you can actually make it more complicated. So for example, root 3 and root 5, those are different. So you can't actually combine those together. So we're going to use those grouping like term skills to harder questions too. So dealing with the root 3s, we can see a root 3 here plus another root 3 here. So we've actually got 3 over there, 1 over there. So combined, we've got 4 lots of root 3. We can then do the same with root 5. So we've got negative 2 over here, and we've got positive 5 over here. That's going to be 3. So that's going to be 3 lots of root 5. Hopefully from this video, you've figured out and you've got the learning objective down. Hopefully you are able to identify what an irrational number is and some common examples. And hopefully down the bottom there, 4 to 7, like we did there, hopefully you're able to perform some basic maths, some simplification of these irrational numbers that you've just learned about.